الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فايربيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
السلام عليكم، اهلا بكم جميعا في جوجل اي او اكستندد 2022. حابين نرحب بكم جميعا في جي دي جي كلاود ايجيبت جوجل اي او اكستندد ايفنت. النهارده هنبدا معاكم في ايفنت جديد، وهو ايفنت جوجل اي او اللي فيه بنتعرف على احدث التكنولوجيات اللي جوجل عملتها في سنه 2022. الايفنت ده هيكون بالتعاون مع فريق المينا دي، فحابين نشكرهم جدا على حاجه زي دي. انا هكون الهوست معاكم النهارده. اسمي جون عزيز، وانا جي دي جي كلاود ايجيبت كو اورجانيزر، وهيكون معايا
عمر خليل، جي دي جي كلاود ايجيبت تيم ممبر.
النهارده مع بعض هنبدا نتعرف على السيشنز اللي هنشوفها النهارده في الايفنت. هيكون معانا من الساعه 10 للساعه 11 وربع جي اس تي سيشن بعنوان جوجل كلاود نتوركينج مع دكتور نبيل. بعد كده من الساعه 11 و20 دقيقه بي ام للساعه 12 25 دقيقه بي ام جي اس تي هيكون معانا سيشن بعنوان واتس نيو ان فلاتر مع باشمهندس طارق العبد. قبل ما نبدا الايفنت حابين نلعب معاكم لعبه. اللينك بتاع اللعبه هيكون اتشير معاكم في الكومنتس دلوقتي. تقدروا تعملوا جوين للعبه دي عن طريق ان انتوا تدخلوا على www.menti.com وتستخدموا الكود اللي ظاهر قدامكم على الشاشه. يلا حاولوا اعملوا جوين بسرعه للعبه، ولحد ما انتوا تعملوا جوين عمر هيشارك معانا الرولز بتاعه اللعبه.
اللعبه دي هي لعبه بسيطه جدا مكونه من 5 اسئله. كل سؤال هو عباره عن صوره بتظهر قدامك، الصوره دي فيها شويه تفاصيل. بعد كل صوره هيظهر قدامك سؤال. خلي بالكم ان الصوره دي بس بتفضل ظاهره قدامكم من 10 ل 20 ثانيه، فحاولوا ان انتوا تركزوا في التفاصيل اللي موجوده في الصوره، وتحاولوا ان انتوا تجمعوا كل التفاصيل في دماغكم كده لحد ما السؤال يجي. هتحلوا السؤال. بعد السؤال بس خلي بالكم ان هو مش بس بيتحسب ان انت حليت السؤال صح، لا، سرعه حلك للسؤال كمان بتزود من البوينتس بتاعتك. بعد ما تحلوا ال5 اسئله هتظهر قدامكم الستاتستكس فيها كل واحد فيكم وجاب كام بوينتس.
خلونا نبدا اللعبه، بس دلوقتي قبل ما نبتدي المفروض ان انتوا تدخلوا اساميكم عشان نعرف مين اللي فاز. فيا ريت تكتبوا اسمكم اللي حابين تعملوا جوين للعبه دي، وبعدين تدوسوا على جوين جديد، وبعد كده الصوره دي هتظهر قدامكم. يلا اللينك بتاع اللعبه تقدروا تلاقوه في الكومنتس. يلا مستنيينكم، هنستنى 10 ثواني بس لحد ما تعملوا جوين، وبعدين هنبتدي اللعبه. اللعبه دي بتختبر الذاكره بتاعتكم زي ما عمر قال لكم، فركزوا في الصوره قوي عشان تقدروا تحلوا اللعبه وتجيبوا بوينتس اكتر. كل ما تجاوبوا اسرع هتاخدوا بوينتس اكتر. طيب خلونا نبدا باول صوره. ديت اول صوره هتتعرض قدامكم النهارده. الصوره دي فيها كوبايه، وفيها حد بيشرب عصير، وفي منديل، وفي طبق، في حد بياكل بشوب ستيكس، وفي زي نعناع في فازه على شكل دب. خلونا نبدأ العد التنازلي عشان تجاوبوا على الأسئلة. يلا احنا معانا يعني خمس ناس جويند اللعبة. خلونا نبدأ العد. هيظهر قدامكم سؤال دلوقتي، والمطلوب منكم ان انتوا تختاروا إجابة السؤال ده. السؤال بيقول which utensil is being used in the picture؟ ايه هي الأداة اللي كان بيستخدمها الشخص في الصورة دي عشان ياكل؟ ابتدوا اختاروا الإجابة الصح، وكل ما تجاوبوا أسرع زي ما قلنا هتاخدوا بوينتس أكتر. يلا معاكم 3 ثواني عشان تجاوبوا. صح. زي ما انتوا اخترتوا، في 3 اختاروا الشوبستكس وفي 2 اختاروا الفورك. خلينا نشوف مين اعلى بوينتس. لحد دلوقتي كافي هي اعلى واحده معانا وخدت 947 بوينت.
في الصورة الثانية زي ما احنا شايفين قدامنا جيتار، قدامنا لوحة، وقدامنا أكتر من كاميرا محطوطة على الرف، قدامنا كنبة، وقدامنا فلور. حاولوا إن انتوا في السؤال الجاي ده تشوفوا تحفظوا كل الحاجات اللي موجودة في الصورة دي على قد ما تقدروا وتجاوبوا على السؤال.
خلونا نبدأ العد التنازلي برضو للسؤال ده. يلا، كل ما تجاوبوا أسرع هتاخدوا بوينتس أكتر. كان في كام كاميرا متعلقة على الحيطة؟ يا ترى كان في كاميرا واحدة ولا كاميرتين ولا 3 كاميرات؟ برضو في 3 أشخاص جاوبوا الإجابة دي صح وفي 3 جاوبوها غلط. كان في فعلا كاميرا واحدة بس على الجي سي بي. سكوره يعني بقى عالي قوي، ومايلي جاية في المركز الثاني وتوم جاي في المركز الثالث. خلونا ننتقل للصورة اللي بعد كده. الصورة دي هيكون في عربية، في أعلام لبلدان، وفي ناس ماشية في الطريق. الصورة دي صعبة شوية فركزوا في كل حاجة في الصورة وكل التفاصيل بتاعتها. في إشارة مرور لونها أخضر، في حاجات أو مطاعم صينية أو محلات صينية. نبدأ الكاونت داون للإجابة. يلا خلونا نبتدي. أنهي علم من الأعلام ما كانش موجود في الصورة؟ في 3 اوبشنز. هل هو علم اسبانيا، ولا هل هو علم البرتغال، ولا هل هو علم ايطاليا؟ العلم اللي ما كانش موجود في الصوره انهي علم من ال3 دول؟ يلا 3 2 1. فعلا هو علم البرتغال، هو العلم الوحيد اللي ما كانش موجود في الصوره. خلونا نشوف مين اللي هيكسب. ولسه جي سي بي في المركز الاول، ومايلي في المركز الثاني، وشين دخل في المركز الثالث. خلونا نشوف الصوره اللي بعد كده، ودي الصوره اللي قبل الاخيره فركزوا قوي فيها.
طيب في الصورة دي زي ما احنا شايفين قدامنا قدامنا فرايز، قدامنا سكينة، قدامنا برجر، قدامنا اعتقد مايونيز او كاتشب. فحاولوا انتوا تركزوا في التفاصيل اللي في الصورة دي وتحلوا السؤال اللي هيجي على طول بعدها.
نبدأ الكاونت داون. خلونا نبتدي. السؤال هيظهر قدامكم دلوقتي على الشاشة، فجاوبوا في أسرع وقت. ايه لون السكينة اللي كانت في الصورة؟ هل هو أسود ولا بني ولا سيلفر فضي؟ صح، هو كان لون أسود. خلينا نشوف الليدر بورد عاملة ازاي دلوقتي ومين المركز الأول. مايلي غالبا بقت في المركز الأول. مايلي في المركز الاول، وبعدها جي سي بي، وبعدهم توم. خلونا ننتقل لاخر صوره معانا النهارده في اللعبه. في الصوره دي في واحد قاعد تحت في البسين بتاعه، قاعد على كرسي احمر، لابس تي شيرت وشورت ولابس جزمه لونها اخضر، وفي شويه ازايز كتير. خلونا نروح على السؤال اللي على الصوره دي، وده اخر سؤال معانا النهارده واللي هيحدد مين الكسبان. يا ترى مين اللي هيكسب؟ ايه البراند بتاعت الكوتشي اللي كان لابسه الراجل اللي كان في الصوره؟ هل هي اديداس ولا نايكي ولا بوما؟ تفتكروا ايه البراند؟ وعليكم السلام. يلا معاكم 3 ثواني. فعلا هي نايكي. خلونا نشوف مين اللي كسب. واللي كسب معانا النهارده هو او هي مايلي. فشاوت اوت لمايلي، مبروك ان انت كسبتي معانا النهارده في اللعبه. وبكده نكون خلصنا اللعبه بتاعتنا النهارده. اتمنى تكونوا استمتعتوا معانا. دلوقتي هنقدم لكم السبيكر بتاعنا وهو دكتور نبيل. دكتور نبيل هو الدايركتور اوف جوجل كلاود تريننج في جيلي فيش، وهو جوجل ديفلوبر اكسبرت عنده اكتر من 20 سنه من الخبره. هو بيعمل جوجل كلاود تريننجز كتير، ومعاه PhD وماسترز ديجري من ليدز بيكت يونيفرسيتي. وهو كمان بيتكلم او سبيكر يعني معروف جدا في جوجل ديفلوبر جروبس دايما، وبيعمل ميت ابس بشكل شهري وورك شوبس دايما بتتكلم على جوجل كلاود. دكتور نبيل النهارده هيكلمنا على جوجل كلاود. وجوجل كلاود هي بلاتفورم بتقدمها لكم جوجل، بتديكم شويه امكانيات او خدمات كتيره تساعدكم ان انتوا تعملوا الكلاود كومبيوتنج بتاعكم. اهلا بيك يا دكتور نبيل.
Ahlan John, Omar. Pleasure to be with you guys today.
Pleasure is
As
ours.
always, thank you. I tried to join the game. I didn't win, but you know, I think
You are GCV?
yes.
I guessed it.
Okay, let me share my slides. Okay, I am on screen, slides. Yes, can you see my slides now? One second, let me just do one thing.
Your slides are clear, Dr. Nabil. We can go ahead.
One second. There you go. Okay, thank you. Welcome everybody to another Google Cloud session. Thank you, John. Thank you, Omar. Now that we finished the game, let's get serious, like taking the technical here. So today's session is going to be about Google networking. One of the main features that basically differentiate Google Cloud from other cloud providers in the way that networking is done in Google Cloud is very, very efficient. It's got a lot of capabilities that allows us to basically do networking in a very easy way compared to what we do on premises, compared to what we use to do traditional way of networking specifically. So what we're going to cover here, first of all, the term VPC, Virtual Private Cloud. This is the acronym that is given to the networking in, not just in Google Cloud, but this is kind of the acronym, the normal term that we use for networking. So when I say network in GCP and I say VPC, we are referring to the same thing, and it is basically it means virtual private cloud. So the networking in GCP, basically it's software defined, is fully managed by Google for us. But underneath that, before I talk about the Google Cloud Service in itself, underneath that there is a massive fiber network that Google use globally. So Google, they own their own network. They laid thousands of miles of fiber network across the globe, connecting data centers. So whatever you see in blue, this is what we call regions across the globe. And in the region, we will have 3 data centers that have these services, VMs, databases, storage, serverless services, fully managed services. So all those kind of infrastructure sits in data centers that Google has built globally, connected by a super powerful network, under the sea cables, over the land. So that's a network that's owned by Google, connecting this what we call regions and zones. So within that regions and zones, then Google built their services. And just a couple of comments in here about this network, just to give you some kind of indication how powerful is this network. So Google in itself, beyond what we use for Google Cloud, they have their own services. They have the YouTube, they have the Gmail, they have Google Search. So they have about 7 or maybe 8 now applications that serve 1 billion user plus. YouTube actually 2 billion users. So you can imagine, in order to drive or to serve this scale of users for each of these applications, the infrastructure has to be very, very powerful, robust. The networking has to be really solid with high resiliency, high availability. So all this cabling that you see here, there is always 2 cables side by side. So if there is an issue with one, there is always another one that takes over, connecting all those kind of data centers across the globe. So on the top of that, Google have put in a technology on top of that, software defined. So it's not for us to go and provision switches or any network devices or any routers, any firewall devices. So Google Cloud as a service for networking is also software defined, which means I can just provision that over the platform. I just log in, use the service like we're going to see later on, and create a network just with 2 clicks of the button, decide where I need to, which regions I want to connect to, which regions I want to use to provision and leverage other Google Cloud service like virtual machines, for example. I can create a network, and then from that network, I can connect 2 regions, and then I can have virtual machines into those 2 regions, for example. So VPC object, or the network object that we have, obviously we have projects. A project is the main component. So without a project, I won't be able to create networks. So that's the hierarchy. On the top, I should have a project. And in GCP, it is the first thing that I need to create. And in there, I can create other services. And from them is networks. So networks, the first thing I need to create before I even create virtual machines. So we're going to see what type of networks we have: default, auto, custom. And obviously, we segregate or subdivide our networks in subnetworks, the same way we do in traditional networks. We subdivide them in subnetworks, and then obviously this is to connect those regions and zones. Obviously, so we will have subnets in regions, and each region will have the zones, which is the data centers. So how can we basically leverage the networking in there? And then obviously from these networks and these subnets, we'll provision IP addresses that will be divided into internal, external ranges. And then from there, we can, when we create a virtual machine, we can have an IP address from this network, from this range, and then this virtual machine will be able to communicate with it. We'll be able to SSH to it. VMs will be able to talk to each other, communicating, maybe sending data from one virtual machine to another, things like that. Because without an IP address, without networking, you can create a powerful virtual machine with so much CPU memory, but it would be kind of useless because we won't be able to get to it without a network. And then what's going to help us with networking is routing. How do we route traffic in Google Network with another kind of software-defined service here? So there is no appliances like a router that I need to devise in there, or firewalls as well, to have control over which traffic am I allowing to go from one region to another or one VM to another. So let's deep dive and look at these things that we have here. Again, like I said, a project, this is where I'm going to be creating services, and from there, network is one of the services that we can create. So without a project, I won't be able to create networks, because this is where you will get billed for resources. So Google are going to bill you per project. So a project will be linked to a billing account that has a credit card attached to it, or whatever payment mechanism you have agreed with Google to have. And a network can contain up to 5. I think this has been now updated, or we can have more networks in here, up to 15. But that's just like a soft limit. This is what we call a quota. So a quota per project. So if you need more than 15 networks, you can just ask Google to expand or give you more on the quota for networking per project. And then when you create multiple networks, we would talk about sharing them. We need to peer them, because when you create network, basically you are segregating resources. So if I create two networks, that means these two networks, they are completely separate. The resources inside them won't be able to get to each other unless we use another mechanism, peering or shared or whatever. So the network itself, when we create, is just like an abstraction, meaning it's just like this is a VPC, give it a name, and then it has no IP addresses whatsoever with it, unless I started creating subnets in it afterwards. So it can have like nothing in it to start with, and then when I start creating subnets, then I will be able to have this range of IP addresses per subnet that I can give to my VMs and things. And we're going to see one of the main features is these subnets or these networks, they are globally kind of distributed. So and a VPC network spans the whole globe, and I will explain that a little bit later in there. And then we can contain these networks. And like I said, these networks that came in three flavors: default, auto, and custom network. So what is a default network? What is an auto? What is a custom? I think this is where I need to show you on the console. Let me just maybe bring, sorry, we're not doing BigQuery. So let me just log into the console and just give you a feel of how does that look like from the console itself. So this would be the GCP console in here. So when I authenticate, I've got this platform in here. So I can go to dashboard and I get this hamburger menu here where I can go to VPC networks. So when I go to VPC networks, I can create multiple networks in here. So you can see here, I've got what we call a default network. And a default network, this is something I get by default. So Google Cloud will create this for me automatically. When I create a project, by default, I get what we call a default network. So what is a default network? A default network, like I said, here we're dealing with, like I said, I'm not physically creating network cabling. That's the underlying infrastructure that's already done for me. So Google have given me this layer, an abstraction layer on top of that I can create network as a software-defined network on top of that. So this default network, if I go to it here, if I just, let me maybe make this a little bit bigger, maybe just to visualize that. So what you can see here, I've got regions. So these are all the regions, like we said, cities across the globe. So if we see that, maybe the latest, if I go to Google Cloud locations, and we can visualize that from here. So Google, they have 35 regions and 103 zones, which means they exist, these data centers, in 34 cities across the globe. So everything you see here in blue, this is what operational. There is something that coming in the very near future, like Berlin, whatever. There is Saudi Arabia, Dammam, Doha in Qatar. This is what is coming in the region. So, and this, like I said, this is what connected through this super powerful network that Google owns. So these are basically all those regions that we see here. So whatever you see, these are the blue boxes, pretty much the blue dots that we see. So US, Europe, US West 1, Asia. So 34 of them. Is that right? Is that what they said? If I go 34, but here we see 35. So this is an indication that something new is cooking. So something is coming up very shortly. So they already provisioned. They haven't announced it yet, but yeah, this is probably something in Europe that is coming up, maybe Berlin or something that is already live. So they are in latest stages to make it available, hopefully shortly. So what it's going to do, like you see here, it's going to create a subnet in each one of these regions across the globe. Okay, so 34 subnets, which means when I go to create virtual machines, I can create a virtual machine in any region across the globe. So what does that allow me to do? Let's go and have a look at virtual machines, for example. If I go to VM instances here, so what I can do, I can quickly go and create a couple of virtual machines in that default network. So demo 001 or 01 or whatever. And you can see here, these are all the regions that we can choose from. So I can pick up two things, maybe two regions in Europe, Belgium, 3 data centers each in those regions. So I select any one of them. I can select any configuration, CPU, memory, whatever. But here we are interested in a networking piece. So we can go to the advanced options. So under networking, we select in a subnet in that region that we selected from the default network here. So, and I can go and create, and I can go and create a different machine in the same network, these default networks. So I can call it demo 02, and I go and create it in a completely different country. So I can go and create it in, let's say, Netherlands, one of the data centers. So you can see here, you know, I'm in a completely different country and I'm creating VMs in different countries and I'm basically putting them in the same network. Amazing. So if you think about it, if you try to do this on your own data centers, okay, you need to take maybe a flight, do something today, tomorrow fly to another country, go to that data center, create that virtual machine. And on top of that, there's a lot of complexities in order to get these virtual machines to talk to each other. But here we are in the cloud. I can use the same network that I've selected, that I've got available, and I'm creating another subnet. This is another subnet in that region, not the previous one. So the Belgium has got its own subnet in there. This is the subnet that is in Netherlands. And I go and create that. Now, what things I can do with this now, I've got 2 VMs in completely 2 different countries. So if I SSH to one of them here, I would be able to ping the other virtual machine in the other country over the private IP space internally, as if they are in the same data center. So I'm not using external IPs. I'm not going through the internet in order to do that. So this is within the Google network. So I'm not going through the internet in order to do that. So if I ping demo 02 or even DNS, internal DNS should be working, but it's not. So there is DNS issue here, but I can pick up the internal IP of demo 02. So if I want to ping that, am I on? So there you go. So I'm pinging the internal IP address of another machine in completely different country, and I'm getting 7 millisecond latency. Super, super fast. So these kind of going from Belgium to Netherlands with sub 10 milliseconds, it's insane if we got this kind of latency. So super, super fast network with internal IPs in them. So if I was to do that on a physical network, that's going to be probably weeks or months of work because you need to create network in one region, another network in another region, and then there is a lot of kind of switches and routers in between in order to create that network. So even the other cloud providers, they don't have this concept of a global network that spans multiple regions. So in AWS or Azure, networks are regional. So you create in one region, and then you do other configurations in order to peer networks to talk to each other on that sense. So That's kind of what default network can give you. So this is the default piece of the network. So the other two networks that we can have is what we call auto mode network. So the auto mode network is very similar to the default, except that I have to create it, and it will go and create for me subnets across all those regions, segregate into kind of its own ranges. So there is no IP overlapping there, and I can do exactly the same. And then the other one is custom. So obviously, when you create this auto mode network or use the default network, it's massive network. So you need to basically take care of all these subnets in multiple regions. And if you think about it, there is no company that they might have like presence on all the regions. It will be a very kind of takes a long time to maintain that. If you start creating virtual machines in different regions, you need to take care of the firewalls, which VM needs to talk to each other. So let's say if you have an application or you have your users spread in, let's say in Asia, in Europe and the US, you're just going to create a custom network. So the custom network, you will be in control, or where do we create these VMs? So in that case, I've got create the subnet, sorry. So I can create in the US East one, US Central one, or I can have this one with just one US East one. But it's very easy to create. So you go create VPC, you give it a name, demo, GDG Egypt, whatever name. And then when you go here, you just specify you want a customer auto. You can see your auto goes and create all these subnets for you automatically in there. If you are using custom, then you have to create a subnet. And notice here, I am in control of the size of the subnet. It's no longer /20, which is a big subnet that is give me a lot of IP addresses out of that range. So here I can start small as possible in my subnet. And I can call this Egypt, but it's not going to be in Egypt. But it's no, we don't have a region in Egypt. Hopefully in future we will. And you can say, okay, I want this in whatever, Europe is 4. Give it an IP range. I can start 192.168.168.0/ let's say 29, whatever. And I can create that subnet. What is the issue? Yeah, I think. Okay. Done. Is this how I created true? Just want one. Okay. And that's it. So I can create. I'm in control where my subnets are going to be. So these are the kind of the 3 types of networks that we have: the default, the auto, and the custom. Okay, what kind of design is going to give us here? So what can we do with this kind of network being global? So the idea here, like I said, imagine this is a project here. And we said we can create 5 networks or 5 VPCs, okay? And they could be custom, they could be, or they could be the default or auto. So the idea here, you can see we have multiple regions, okay? And we have multiple networks. So when I create multiple networks like this, network 1, network 2, okay, so resources inside them, they're completely segregated, as if they are physically segregated if you create this network. So they won't be able to talk to each other here. So for example, VPC 3 or network 3 and network 4, I can create one VM here and one VM here. They are both on ES East 1, but they won't be able to communicate with each other with an internal IP. They're not going to go over the internal network, okay, because they are separated. They're completely segregated in here. The only way that these VMs, they can talk to each other is to give them a public IP, and then they go over the internet and come back pretty much go through the internet. But it's going to open up security issues. You need to pay for egress as well. So, you know, it's not ideal. It's not the very efficient way to do that. Whereas this one here, we've got one network. We said the network is global. So like I said, I can create a VM in the US and I can create a VM in Europe, but they can talk to each other over the internal network of Google, over the private IP, even though they are completely two different continents. And this is the power of networking in Google Cloud. So it gives you this kind of stuff. So I don't have to worry about anything else. So something that is going to cost you a lot of money if you want to do that on a physical data centers. So here, Google, they've connected all those regions already. They give us an abstraction on top of that we can leverage and create over the same network VMs that can, you know, talk to each other over the internal IP space. So super, super powerful in there. That's going to open up lots of capabilities for us, especially if I'm doing hybrid connectivities. Let's say I've got a data center already physical, and I'm using GCP as well to, I don't know, leverage some GCP capabilities like VMs that are running my applications in the cloud and things. And I want to transfer data. I want to communicate with my network from my on-premises. So I need a VPN. So here, when I use a VPN, okay, imagine this is US West 1 region in the US. This is US East 1. So they are completely, probably there is 6,000 miles between these two guys here. Or this could be Europe, for instance, because we said the VPC is global. So that could be Europe, or it could be Asia, or whatever, Australia, whatever the case might be. And my data center could be in the US. So what I can do, I can create a VPN gateway, okay, in the US region to connect my on-premise with my VMs in the US. But once I get this connection here established, my data center VMs or resources, if this is Australia, I'll be able to get to the Australia over the internal IP, which is really, really powerful. I don't need multiple VPNs for multiple regions. So I'm extending my network to my on-premise data center just with one VPN gateway. So this is another thing that VPC being global, or the network being global, you would be able to connect to it, to your physical data center, and be able to access all the resources globally over the internal network, over the internal IP, like we've seen in those two VMs. So that's VPC being global. So those subnets that we created, they are created in those regions, let's say Netherlands, Belgium. So remember, those regions, they've got 3 data centers, so which we call zones. So imagine we might have like another zone in here. So in that case, all these VMs that I'm going to be creating in multiple data centers, they're going to be using IPs from the same IP range for that region. So like I said, VPC, the network is global, globally distributed across all the regions. Now the subnets that I created, they span all the data centers. They span all the zones in the region, which opens up a lot of capabilities in there. For example, a single firewall rule can apply to both VMs in here. If they have the same tags, they are on the same network, I can give them the same firewall rule to apply to them. The other thing that I can, the IP range, sorry, that I'm going to be using for the firewall is going to be from the same subnets. And the other thing you can get with that is resiliency, high availability. So if I want to do failover of VM, maybe if I lose one data center, I can just pick up the IP address of that VM and use it on the other one. If my data is already replicated, then that's kind of really easy to do. So I don't have to reconfigure any routing or any routing tables or switches or anything. So I can just plug in the IP address in them. In fact, there is a product in GCP, Cloud SQL, for example, which works in that way. So that failover is automatic. You would have an instance, a primary instance of the Cloud SQL database. And then if a data center fails, of the whatever the instance failed, it automatically fail over. So it will change the IP address automatically for you. Data is already replicated. So that mechanism is already in place because we're leveraging capabilities of subnets being global resources or regional resources. They span all these zones in the region. When it comes to these subnets, like I said, you can expand them. So if you start small, especially in the custom ones, let's say the one that I've done /29, for example, that gives me about 4 IPs, because in GCP you have 4 IPs, they're always reserved, so you can use the other form. If I consumed all of those, I need more VMs to create in the same region. I can just expand that without having to reboot any machine. So very, very easy to do that. So I can just, if I go to this one that I've created here, this subnet, if I want to expand it, I'm just going to edit 28 to have more, another 8. So that will have, instead of 4, I'll have now 12 IP addresses from that range. So I can create more VMs within that same thing. So just edit that, save. I don't need to reboot anything. It's just going to be distributed because it's all software defined. It's going to update the routing table automatically and going to distribute it across all the VMs for me, so they know where the routes are and what the new IPs are that have been added to the subnet. And okay, as you expect from a network, you get internal IPs. You can expect external IPs that you can create from that. So and powered by an internal GSTP, the internal DNS. You can reserve IPs. But when you create a VM, you need to have at least one internal IP, and then you can have extra IPs as well. Internal DNS is already there. And then when you create an external IP, it's not visible from within SSH. So your SSH, you do if config, you're not going to be seeing that. Similar to, when you have your machine on your local network, on your Wi-Fi at home, if you do if config or IP config, you won't be able to see the external IP. You're just going to see the internal IP range address. The IP address is going to be, the external IP is going to be at the router level. So you'll have to do something like, you need to curl from what is my IP externally to see what's your external IP of that VM, for example. So here is the same concept. DNS resolution is already done for you. So mine that I've created, I had an issue. So it should have just resolved my host name there. I should have just done ping demo 01. You should have replied, but each instance when you create it, it has the fully qualified name in this format, hostname.c project ID internal, and that's all managed for us internally. So all our resolution doing for us internally. For the external resolution of IPs of services, you can leverage Cloud DNS. Cloud DNS, one of the most powerful service in GCP. It is completely fully managed, powered by a lot of kind of latest technologies. It has 100% SLA, so it never goes down. So if you have you need a DNS service, even if you're not using GCP, you can use Cloud DNS in there. So basically, do the translation of your services to an IP address. DNS records for extended address can be published using DNS service outside Google Cloud. Like I said, they can be hosting Cloud DNS, wherever. So another service like you can have. Again, translate domain names into IP addresses. Very, very low latency. So we leveraging capabilities of this powerful network that is Cloud DNS is built on top of. Highly available, so 100% uptime. It never goes down because of this, globally distributed network across the globe. So, you're always high availability. If one region goes down, there's always another region that takes over. And you can create and update millions of DNS records through the UI. You can do it through command line or the API, through the API, REST APIs as well, if you want to leverage that from programmatically. That's not the old story. So the subnet ranges that we created, we have primary IP addresses. So the subnets that we've seen, these are primary IPs. So I can give those IPs to my VMs. But if you're using, for example, microservices, using containers, Kubernetes clusters, you will find out that you will be running multiple applications in one VM. And in that case, you might be like maybe 10, 20. So the idea here is to not give a primary IP for each of these containers. You can leverage secondary ranges, which we call alias IP addresses. So each primary range will come with a secondary range that we can use for this purpose. So we're not kind of consuming or exhausting our primary IP, which usually primary IPs are used with the NICs that are associated with that. And by the way, VMs can have up to 8 NICs. So you can have up to 8 primary IPs, and then you can use secondary IP ranges for containers running or applications running in there that want to have their own IPs in there. So when it comes to routing, again, routing is also completely managed for us by Google, completely software defined. So a route, we know what should route. A route is basically when you, for example, the example I take earlier, when I want to ping one machine in Germany or Netherlands to Belgium, needs to have a route in place for that machine to need to know what route needs to take to reach the destination. So it's basically directing the packets to destinations that are outside our network or inside our network. So that's completely, like I said, like globally distributed, fully managed, software defined as well. So you can see this is our, you can think of this our routing virtually or the cloud version of the router. Basically, it's an abstraction where, it contains all the routes. So when I do an update to adding a new machine, adding new subnets, the new route gets added automatically and globally get distributed across all the VMs. So the VMs will be able to access the routing table and know which routes they need to take according to this. If I add a VPN gateway route, it's going to be added to the routing table as well. And if I go to the console here, if you go to my VPC network again here, so if I pick up, let me pick up a simple network here, because this default is going to show a lot of routes. So if I pick up this one that's got 2 subnets, you will see that when I create subnet, it creates the routes for me. So it will create the default route to get to the internet, so destination IP anything, and then it will create the default routes for me to reach the other subnets. And that's why I was able globally to be able to reach other subnets in other regions, because the routes are already done for me. For each subnet, create the routes for the destination of the other. So these are the 2 for the 2 subnets. But if I look at, this is peering, this is something else. If we get a chance to, at the end of the session, we'll talk about that. But if I go for this default one, you will see every subnet has got its own route. So we can reach to. So you can see here, default route for all the subnets, as you can see. And this is, again, managed for me by the VPC service in here. Okay. And again, all the route is to map the traffic to the destination. So we have a routing table. Like I said, it gets distributed to all the VMs in my network. So if I update that, it will be automatically distributed. For example, earlier, if we need to expand the subnets, it's going to update the routing table, distribute it across the VMs without these VMs having to reboot. So I didn't need to reboot that or change the IP address, so they know where the route is going to be. And then according to firewalls as well. So the route is there just to allow the traffic to, but if I want to, if there is a firewall to say, okay, this traffic is not allowed, obviously that's the way we control if the traffic is going to be allowed to or disallowed, is going to be allowed or denied. And these routes, like I said, they're going to be created when the subnet is created automatically. And this is what allows subnets on the same network to communicate. So this network, remember, we're talking about a global network. So this VM could be sitting in, this one could be sitting in Australia, this one could be sitting in US. So the other side of the globe. And this is what allows to communicate. So if I don't want them to communicate on the same network, I just create a firewall rule to say, okay, traffic coming this VM, not allowed. Again, for the routing, like I said, is going to be distributed, automatically updated, and so on and so forth. Okay, so that's routing. So how about firewalls? So firewall rules, again, here is completely software defined. I'm not bringing in like an appliance or creating a VM and say, this is a firewall that I need to configure. This is kind of by default, I'm going to get that, and I just need to configure a firewall rule to be able to do that. So it is kind of sitting on a global network. So it's a distributed firewall. Again, you can see physically we have this physical network globally connecting all these regions and zones, and Google are putting layers, networking layers, technologies, software defined, the VPC, cloud DNS, routing, firewall on layer on top of layer of this super powerful networking there. So the firewall, this is what's going to allow us to the connections to allow or denied. They are stateful, and we have some implied deny or ingress and allow or egress. What does that mean is, you know, when you create a network, there are some kind of firewall rules that are already created for me. I can't change them. So if you want to do that, if I scroll down here, and you can see here firewall rules, and the default network, it's got some default network that allows, for example, SSH. And this is why when I use the default network, I was able to SSH to a VM because there is a firewall rule that allows that. If it was a Windows machine, I would be able to RDP. I was able to ping because there is an ISMP rule in there to allow the ping to traffic to happen or to be allowed. And also we have this allow custom. This is what allows kind of subnets to talk to each other. So they're already a firewall rule to allow all the subnets in different regions to allow that traffic. So the route is there, so I can control if the traffic will be allowed or denied with a firewall rule. But notice here we've got two implied rules, which means deny or ingress, which means if I have a public IP address on my VM, I'm not allowing anybody outside to reach to it. But also I have allow or egress, which means if I have a public IP address on my VM, I'll be able to reach the internet. That's what it means, those implied. And I can't change them. But notice here, they've got this priority number here. So basically what it means, I can override them. We're going to see that in a minute. So these are the firewall rules. Again, software defined. I don't have to manage anything. Completely managed for me by Google. They compose of these parameters. So again, let me just show you briefly here. If I go to firewall rule, how do I create that? Sorry, this is policy. So policies is more advanced thing. We're not going to cover that today, but this is a firewall rule. I can do demo, and basically I can allow the logs on that to see later on if I'm doing some troubleshooting, if some firewalls are not working. In the logs, it will tell us why in there. And I can specify the network where this firewall is going to be applied. They are network-based at the network level. And then the priority, I'm going to talk about priority in a second. But then I can just specify the direction. Is it traffic that is coming into my network, or is egress? Is it for the traffic that is going out from my network? And then I can specify allow or deny. Am I allowing this traffic, or I'm basically stopping that traffic to go through? And then I can specify my targets. So from this VM, from this network, which VMs this firewall is going to be applying. So I can go and say all instances in my network. So whatever VM is in my network, I apply this VM, or I can specify tags. So tags is basically just a tag that I can say. So maybe I have like a front end server. So I can put this here. a tag, I'm going to write it. And on my VMs, if I open this in a new tab, then what I can do, let's say this VM is in that network that I'm creating, I can give it a tag. So I can say edit, and down here I can say front end. So which means this VM is part of that network, plus it's got this tag. I need to make sure that spelling is correct and thing. And in that case, when I save that, this firewall rule that I'm going to be creating will match the tag and it will apply to that. And then for the source, I'm going to specify kind of what kind of IPs I want the range to come from. And this is what we said earlier for the subnets. When we can say a firewall rule from the same for all the subnet in my region could be the source of the firewall rule, for example. This is what that slide was talking about there. And then I can say, okay, what kind of protocol and ports I want to allow. I can do allow all, which is not best practice. I need to be specific. I want to have TCP, UDP, other firewall rules, whatever. And then I've got this priority field in here. What it means is, because as your network grows, as you start creating many resources, you have many people working with many firewall rules. You might have a conflicting firewall rule. So you might have, like, you have created a firewall rule that says allow for the same specification. Somebody else went and say denied. So they work in the same network, they are working with the same tag. And in that case, what's going to happen, the firewall rule will have this priority item. It's going to check, okay, this one is saying allow, this one deny. So which one is going to applying in there? So it's not going to throw an error at you. It's just going to go and check the priority. So if a priority, the higher is the number, this number here, oops, the lower is the priority. So if you want to override a firewall rule that is saying, for example, allow, and you want to deny it with the same specification, the other one was 1000, I want just to create a deny one, and I create that with a lower number, maybe 150, whatever. So this will take precedence. Now, in situations where even the priority number is going to be the same, what's going to happen in that case? Then Google, they don't take any risk or assumptions of trust that the firewall is allowed. It's just going to go with a deny. So it's not going to allow the traffic. So if there is an issue there, then this is what the firewall rule logs are going to be playing. So somebody's saying, okay, I've allowed this traffic, why is it not happening? You go to the logs and you will find that there is a firewall rule that's saying deny. So you change the priority pretty much for that to allow the traffic. So that's as easy as it gets with that. So this is what we're talking about: direction, source, destination, protocol, action, priority, rule assignments per network, per all the network, all tags or whatever. And again, you can, like I said, you can play with this. You can do egress rules, allow, deny, traffic from external, internally, egress basically for traffic going out, ingress for traffic coming in, and you specify basically to allow or deny that traffic based on those situations. Okay, so a couple of more things here. As we said, we can create multiple networks in here. So how do we get them to talk to each other later on? Maybe I segregated resources in different networks, or I created multiple projects. And now I need my VMs in these projects or these networks to talk to each other internally. I don't want them to go to the public internet and come back, because that's a security issue. There's egress costs that come with that. So we've got two concepts in here. We've got what we call shared VPC. So shared VPC, the VPC that we've been creating, either it's and then when later on I want to have different resources talk to each other that sits in multiple projects, I can share that network with multiple projects in there. And when I share the networks, what's going to happen is I will be creating what we call, or selecting, or somebody, the organization admin, the most powerful admin of all my project in my organization, will be delegating somebody we call shared VPC admin. He will be selecting a host project to host the network that's going to be shared with other projects. Other projects, they can have their own VPC, but I want them to be sharing subnets from these hosts or main project here. So you will have a shared VPC admin. He has his own VPC. He's going to say, okay, this VPC that I've got in my project, I want to share it with other projects. So I can give one subnet to this project, one subnet to this project, one subnet to this project from the same VPC here. So since they are subnets from the same VPC, meaning that I'm going back and having VMs on the same VPC that is globally distributed, so they can talk to each other over the private IP in that case. So like I said, you've got an organization admin. They will nominate somebody with shared VPC admin in there. This guy will enable shared VPC for that project. He's going to attach what we call service project, the other ones. They give them some permissions to be a network user from that, and then they give them basically some subnets they share with them. Then you get access to some of all the subnets in a shared VPC, and then in these projects here, will be able to consume these IPs coming from here, and they will be creating VMs. So everything from all the projects, they will be able to talk to each other over the private IP range. So this is an example here. This is shared VPC. It's got its own network. It's got different subnets. So I'll be able to give a subnet to one project, another subnet to another project, and another subnet to another project, and give them permissions for each. And then everything, all these VMs from multiple projects will be able to talk to each other with private IP, not going to the internet and coming back. So this is one VPC shared across multiple projects. We can also do VPC peering. So in that case, we can have one VPC in one project peered with another VPC in another project, so they can talk to each other over private IP. So they stay in their own project in that case. But here we need to make sure that the subnets here, they don't overlap. I'm not using the same ranges. And in here, you will have two network admins. They need to configure each side of this in order to see that. So on the console, it will look something like this. So if I go to, I've got a couple examples here. So here you can see I've got VPC peering. Yes. So this I've got, you can see here I've got this network, main VPC network, and I've got a completely different network called this that is sitting in completely different projects. So I paired them together, and you can see here, this is the destination. So and if I create VMs in this network and the VMs in this network, even though they are completely in two different networks, two different projects, maybe two different regions, they will be able to communicate over the internet, the internal Google network with internal IPs. Shared VPC is the same, but in this case here, we're dealing with projects. So here I've got a host project, this GCP security, okay? And I'm sharing it across, I've got two subnets that this is the attached protection. I've got two other projects here, GCP MENA 0201. So these are two different projects. So I'm sharing with them two subnets. I'm giving a subnet to one, subnet to one. So in that case, I've got three projects be able to share the same network in there. Okay, let me see if there is any questions in the chat. What is the difference between the two? Let me just move back here. is just configuration perspective, admin perspective. So this is VPC peering. So how do we compare? So consideration. So shared VPC, it doesn't work cross organization. So it has to be projects from the same organization. It doesn't work within one project because we are linking multiple projects to be able to share the same VPC. And it's just one admin, centralized model of admin. So one admin who's going to do the configuration of shared VPC. Whereas for peering, we are using VPCs from multiple projects, maybe multiple organizations. So it will work cross organization. It will work within one project or multiple projects. But again, from admin perspective, I've got two configuration items from different. I need to configure the peering from two sides. You might have, especially if you have two organizations, you might have two networking admins that are dealing with the two sides. So decentralized model with networking. Okay, this is an example, and you can mix and match. So you can have shared VPC, and you can peer it with another network. So that's also possible. So you have a hybrid configuration with peering and shared VPC. So you can have in the same organization multiple projects using shared VPC, and I can peer with another network sitting somewhere else. So all these VMs would be able to exchange traffic over internal IPs. Nothing is going over the internet. So very, very efficient traffic, very secure, and opens up a lot of capabilities here. We're collaborating with another organization, so without having to go over the internet, without having to create VPN, manage firewall rules and externally and things like that. Okay, and looking at the time, I think that's all I've got for you. So I've got other stuff in there, but obviously small session. So maybe in the future, we're going to talk about other things, hybrid connectivity and other stuff as well. So this is back here. So thank you again for your attention, and just go back here. I don't have a hybrid connectivity there, but yeah, thanks again. Thanks for having me. If there is any questions, happy to take them. I think you can share, you can connect to me through LinkedIn or Twitter. If you have any questions, happy to take them here or later on. Thanks again, and hope to see you again in the future.
شكرا جدا يا دكتور نبيل على حضورك معانا النهارده وعن السيشن اللي في الحقيقه كانت اكتر من رائعه وعن المعلومات القيمه اللي استفدناها النهارده. اتمنى كلنا نكون استفدنا وتعلمنا حاجات جديده عن جوجل تكنولوجيز النهارده. اللي قدامنا ده هو الهاندل بتاع دكتور نبيل اللي عايز يتواصل معاه ويساله اي سؤال.
شكرا جون and شكرا للفريق العمل. Like they said, well done, keep up the good work, and شكرا مرة ثانية على الاستضافة. شكرا
جدا يا دكتور نبيل على وجودك معنا. في السيشن الجايه هيكون معانا باشمهندس طارق العبد واللي هيتكلم معانا عن فلاتر. السيشن دي هتتبعت اللينك بتاعها في الشات دلوقتي وهتبتدي خلال 5 دقائق. اتمنى كلنا ننضم للسيشن الجديده وننضم بسرعه علشان قدامنا بالظبط 5 دقائق والسيشن تبتدي. يلا استناكم هناك.